Myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In the last session, we have seen about classic problems on synchronizations. What are they? Reader-writer's problem, producer-consumer problem, and dining philosopher problem. And we have also seen about monitors in process synchronization. So today we are going to... Hello everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In the last session, we have seen about classic problems on synchronizations. What are they? Reader-writer's problem, producer-consumer problem, and dining philosopher problem. And we have also seen about monitors in process synchronization. So today we are going to see in this session about deadlocks. So let us see the overview of the presentation. In this overview of this presentation, we are going to see about deadlock definition, what is a deadlock, and what is deadlock characterization, and methods for handling deadlocks. So we have seen about methods for handling deadlock. So let us see the first definition of deadlock. So deadlock is a situation where a set of processes are blocked because each process is holding a resource and waiting for another resource acquired by other processes. So what is a deadlock here? So suppose consider example, when two trains are coming on a same track. So two trains are coming on same track, T1, T2. So same track, and there is only one track. So they are traveling only on one track. None of the trains can move once they are in front of each other. So they are both facing each other. So no train 1 cannot go this side, train 2 cannot go this side. So what here happens? Deadlock. So the two trains are here dead. Why? Because train T1 cannot move, train T2 cannot move. Why? Because they both are traveling on same track. This is what about deadlock. Similarly, a similar situation occurs in operating system when there are two or more processes that hold some resources and wait for resources held by others. So one process is holding some resource, so other process or other resource also want to hold that same process that cannot be accessed or done by this process. Why? Because until and unless it completes or removes the resource 1, then only resource 2 can enter. So until and unless the process holds only one resource and releases one resource. So that is what about deadlock in operating system. For example, consider the below diagram. Process 1 is holding resource 1 and waiting for the resource 2, which is acquired by process 2, and process 2 is waiting for resource 1. So see, process 1 is assigned by resource 1 and process 2 is waiting for resource 1, and resource 2 is assigned for process 2. See how it is happening. So one process is assigned and one process is waiting. One process is assigned and one process is waiting. So how here it is happening? It is happening like deadlock, right? So until and unless it removes the resource 1, only process 2 can enter, and otherwise it cannot enter. Why? Because the process or resource already assigned to the process P1. So R1 is already assigned to process P1. So P2 is waiting for resource 1 until and unless resource 2 assigned to process 2. So until and unless process R1 releases only, then only P2 can access this R1. Otherwise it cannot access. This is what about deadlock. So let us see the characterization of deadlock. So in this characterization we have 4 conditions. What are they? Mutual exclusion, hold and wait, no preemption, and circular wait. So let us see about first one, mutual exclusion. What do I mean by mutual exclusion? There should be a resource that can only be held by one process at a time. In the diagram below, there is a single instance of resource 1 and it is held by process 1 only. So resource 1 is allocated only by process 1 until and unless the process P1 can access only resource 1. After the completion or removed by the process, then only P2 can access resource 1. Why? Because only one process can handle only one resource. That is what about mutual exclusion. Here it says that there should be a resource that can only be held by one process at a time. So one resource, one process can be accessed at a time. That is what about this mutual exclusion. So next, what do you mean by hold and wait? A process can hold multiple resources and still request more resources from other process which are holding them. So see the diagram. Process 2 holds resource 2 and resource 3 is requesting for resource 1, which is held by process 1. See, resource 2 and resource 3 are allocated to process 2, nothing but let us say P2. So P2 is requesting for resource 1 and resource 1 is allocated to P1. So until and unless it completes or holds its resources, no other process can be accessed. Why? Because here one process is holding or allocated, other is under waiting, other is allocated. So one should be under hold, one should be under waiting. So who are waiting, who are allocated here? So resource 1 is allocated and P2 is requesting for resource 1. Who are under waiting? R2 and R3 are waiting. Why? Because P2 is waiting for resource 1. Until and unless resource process P1 removes only, P2 can access the resource 1. Why? Because already it is allocated to P1. So only one process can hold, only other process can be under waiting. That is what about hold and wait. Next, no preemption. A resource cannot be preempted from a process by force. So here a resource cannot be preempted from a process by any kind of force. A process can only release a resource voluntarily. So until and unless it only releases, only other process can allocate. Otherwise it cannot allocate voluntarily. In the diagram below, process 2 cannot preempt resource 1 from process 1. It will only be released to when process 1 relinquishes it voluntarily after its execution is completed. So here resource 1 is allocated to P1 and P2 is requesting for R1 and R2 is allocated to P2. R2 is allocated to P2. So what the diagram says, process 2 cannot be preempted resource 1 from process 1. So process 2 cannot be preempted by resource 1. It will be until and unless P1 releases R2 only, then it goes to P1. Why? Because already P1 is allocated to R1. So relinquished it voluntarily after its execution is completed. So after the completion of execution, P1 releases R1, then P2 can allocate R1. So that is what no preemption will be occurred. Next, circular wait. A process is waiting for the resource held by the second process, which is waiting for the resource held by the third process, and so on, till the last process is waiting for a resource held by the first process. So see the below diagram, this forms a circular form. So process 1 is allocated resource 2 and it is requesting for resource 1. Similarly, process 2 is allocated resource 1 and it is requesting resource 2. This form is nothing but circular wait loop. So P1 is requesting R1. So here it is happening, some request is happening and resource 1 is allocated to P2. So R1 is allocated to P2. P1 is requesting again R1. So R1. Again here P2 is requesting R2. Again R2 is requesting P1. So how it is happening? It is happening in circular wait. So they are going on requesting, accessing, requesting, accessing. How they are accessing? It is nothing but in circular wait. So one process is allocated, one is waiting, one is requesting, one is assigned. So that is what about this circular wait. Next, what are the methods for this handling of deadlock? There are 3 ways to handle this deadlock. So what are the 3 ways? First way is deadlock prevention or avoidance, and next one is deadlock detection and recovery, and deadlock ignorance. Let us see our first method for deadlock prevention or avoidance. So what do you mean by prevention of a deadlock? This idea is not let the system into the deadlock state. So here this state is nothing but the system cannot be under a deadlock state. this system will make sure that above mentioned 4 conditions should not rise. So what are the 4 conditions? Mutual exclusion, hold and wait, no preemption and circular wait. So it does not allow these 4 conditions for this prevention. So these techniques are very costly, and so we use these cases where our priority is making a system with deadlock free. So this technique is used for very costly, and this cases is for priority and making a system from the deadlock free condition. So one can zoom into each category individually. So person or one condition can be chosen each by individually. Prevention is done by negating one of the above mentioning condition for deadlock. So above mentioned conditions are nothing but, what are the prevention can be done in 4 different ways. What are they? Eliminate. So first it is going to eliminate mutual exclusion. Next it is going to solve the hold and wait. And next it allows preemption, and it is going to solve the circular wait solution. So these are the 4 different ways for this prevention of deadlock. Next, what I mean by avoidance for this deadlock? Avoidance is kind of futuristic. Futuristic is nothing but the deadlock should be avoided for the future. So by using this strategy of avoidance, we can have to make some assumptions. Assumptions means we can remove some errors. We need to ensure that all information about resources that the process will need is to know about the execution of the process before the execution of process. So by avoiding this deadlock, we can gather the information about the resources that the process need to know about the before execution of the process. Means until and unless the information gathered before the execution, then only the process can share the resources, or else it cannot share. So we use Banker's algorithm, which is in turn gift from Nishitha's to avoid some deadlock. So this Banker's algorithm we are going to see in the next session. So this can be solved by Nishitha's to avoid the deadlock. In prevention of avoidance, we get the correctness of data but performance may decreases. In prevention and avoidance of this deadlock, we get the proper correctness of the data by providing some performance decreasing their values. This is what about deadlock avoidance. So next method is deadlock detection and recovery. If a deadlock prevention or avoidance is not applied to the software, then we can handle this by deadlock detection and recovery. So until and unless the first method, prevention or avoidance, is not applied, then we can apply the software for this detection and recovery. So what are the 2 phases for this detection and recovery is nothing but, in the first phase, we examine the state of a process, check there is a deadlock or not in the system. So first phase is what it is going to check whether the system is under deadlock or not. That is the first phase for detecting or recovery of this deadlock. So if found deadlock, next phase is nothing but, if there is found of deadlock in the phase 1, then we apply the algorithm for recovery of the deadlock. What is the algorithm we are going to recover? This algorithm is nothing but Banker's algorithm. For if the deadlock is found in the first phase, then we are going to apply the algorithm for recovery of the deadlock. What is the algorithm chosen here is nothing but Banker's algorithm. So next, third method is deadlock ignorance. If a deadlock is very rare, then let it happens to reboot the system. So when the deadlock is occurring rarely, then we can reboot the system. Reboot the system means we are going to restart the system. This is the approach that both Windows and Unix takes. So this can be happened in the Windows system and Unix software. We use the ostrich algorithm for deadlock ignorance. So what is the algorithm used? Ostrich algorithm for deadlock ignorance. In deadlock ignorance, performance is better than 2 methods but the correctness of the data. So what here, it is occurring some ignorance to choose the better methods for getting the correctness of the data. So ignoring the deadlock can be chosen by the 2 methods for correcting the data. What is the safe state for this deadlock? A safe state can be defined as a state in which there is no deadlock. So safe in the sense the name itself says it is safe. So there is no occurrence of deadlock. If a process needs an unavailable resource, it may until the same has been released by a process to which it has been already been allocated. So until and unless the unavailability of the resource, the waiting of the other resource or a process which is already allocated in such a sequence does not exist until it is unsafe state. So when it is doesn't exist, so it is under unsafe state. All the requested sources are allocated to the process. So all these resources are allocated to some processes. This is what about deadlock ignorance. So in this session we have seen about deadlock and characterization of deadlock. Characterization of deadlock, we have seen about mutual exclusion, hold and wait, no preemption, circular wait, and we have also seen about methods of deadlock. So if you have any doubts, you can comment in comment box. Thank you.